Good morning, everyone. In previous session, we have started with chapter number 6 grasp, that is general responsibility assignment software pattern. In that session, we have seen that responsibilities, then creator pattern and example for that creator pattern. Then we have seen that information expert pattern, then example for expert pattern with the diagrammatic example. Then we have seen the low coupling pattern. In that we have seen that poor coupling example for poor coupling and example for low coupling. Okay, so now we are continuing with the next pattern, that is controller. Okay, in controller pattern it deals with how to delegate the request from the UI layer objects to domain layer objects. When a request comes from UI layer object, controller pattern helps us to determine what is the first object that receive the message from that UI layer objects. Whenever request comes from that UI layer objects to access something, then that controller pattern helps us to determine what is the first object that receive the message from the UI layer objects. Then this object is called as controller object, which receives the request from that UI layer object and then controls with other. Whenever request comes, that controller will helps us to determine that what is the first object that will receive that message from that UI layer object, and that object is called as controller object. Okay, then it will coordinate with the other objects of the domain layer to fulfill that request. It delegates the work to the other class and coordinates the overall activity. Here you can see the controller pattern. Here we can make an object as a controller. How we can make that object as a controller? If object represents the overall system, if that object represent the overall system, then we can make that object as a controller. Or when that object represent a use case handling a sequence of actions or sequence of operations, that is the session controller, then we can make this object as a controller. Then what are the benefits of control pattern? We can reuse this controller class. We can use to maintain our controller. We can it can use to maintain the state of the use case. We can reuse the state of that use cases. Then it can control the sequence of activities like use cases. Okay, so here you can see the example of controller pattern. Here click on perform, this is the request. Okay, request comes to that UI object. Okay, so that UI layer or UI object layer proceed with the request. Here you can see the controller. Okay, that request comes to that controller, that is perform actions. Okay, what actions to perform? Click on perform. Okay, we have to click on this, click on something. Okay, that means you can say event. Okay, so that request through that UI layer or UI object, it will come to that controller. Then that request comes to that. Here you can see the object A and object B. There are two objects. Okay, invoke action A and invoke action B. Okay, so here we have seen that whenever request comes to that, here when a request comes from UI layer object, here request comes from UI layer object. Okay, then controller pattern helps us to determine what is the first object that receive the message from the UI layer object. Here controller object helps us to determine the request for which object it is. Okay, so it is for object A, or for example it is for object A or object B. Okay, so the controller will help us to determine the request from that UI layer. It is for which object? Okay, if that request is for object A, then it will process with the object A, or if that request is for object B, it will process with that object B. Okay, so this is the work of controller here. Okay, here in controller class is called bloated. Okay, bloated if that class is overloaded with too many responsibilities. If multiple or many responsibilities are assigned to that particular class, that time that class is called as, or that controller class is called as bloated controllers. Okay, so what is the solution for that? We have to add multiple, or we have to add more controllers in that classes here. You can see there is only one controller because there is only one responsibilities for that particular object. If there are multiple responsibilities are assigned, then we have to add multiple controllers here, okay, so that that particular request or particular responsibility is assigned to that particular object, okay. So that controller class also performing many tasks instead of delegating to other class, okay, it can perform multiple tasks, okay. So for that there is a solution. Controller class has to delegate things to others, okay. So controller class has to delegate things to others means that here you can see that controller will pass that request to that multiple objects, okay. If that request is for this object and again another request is there, that means multiple responsibilities are there, then they can, that multiple responsibilities are allocated to that multiple objects, okay, not for single object, okay. So the next pattern is high cohesion, okay. So high cohesion, in high cohesion pattern, the problem definition is how are the operations of any element are functional related. How are that operations are functionally related to each others. That related responsibilities into one manageable unit. Okay, that if that multiple responsibilities are assigned to one particular element, that means that responsibilities are assigned to only a single unit. That means at that time we can use or we will prefer the high cohesion, okay. So it clearly defines the purpose of that element, okay. What are the benefits of that high cohesion? Easily understandable and maintainable, code reuse and low coupling. Here you can see the example of low cohesion, okay. Here in low cohesion, here you can, there is only one object is there, for example student. All the operations are performing on that student object. Here you can see get student details, access db calls, then insert db. This is the example of low cohesion. That means all the responsibilities are assigned to that only one unit, okay. So what is high cohesion here? Here you can see the example of high cohesion. Student is one object and now db is another object. So for student, it will get the details, get student details, and if you want to insert that student details, we are going to insert that student details into that db, okay. Or in that, using that db objects, we are going to insert that student details into the databases. In that we are going to access the db, access database, then db calls and insert database, okay. Here you can see the difference between low cohesion and high cohesion, okay. All the information are, all the operations are performed using only one unit or only one unit. Here you can see related responsibilities into one manageable unit, that is low coupling or sorry low cohesion here, okay. For that, to avoid this, we have to use high cohesion. Here you can see high cohesion means we have to assign responsibilities based on their behaviors, okay. Here you can see student and db, okay. Here easily understandable and maintainable, we can reuse this code, and low coupling, okay. That is all about high cohesion. The next pattern is polymorphism. Polymorphism we have studied in object oriented languages, okay. Ability to take more than one form, okay. That means we are having one function, we can use that function in for different purpose, okay. So here polymorphism in software architecture and design pattern is, or for software pattern, now that polymorphism is a software pattern here. So what is the problem definition for that? How to handle related but varying elements based on the element type. How to handle related but varying elements based on the element type. Based on that element type, how we can handle that elements. So for that, polymorphism guides us in deciding which object is responsible for handling those varying elements, which object is responsible for handling that varying elements, okay. So what are the benefits here? Handling new variations will become easy. Using polymorphism, it will be easy to handle that new variations. Here you can see the example of polymorphism here. The gate area, here you can see we are having three classes: shape, circle and triangle. Here you can see the generalization of that shape class, okay. So here one method is there, gate area. If you want to calculate the area of any shape, then it will be confusing that which shape we are having and which and we are going to calculate the area for which shape. Okay, so for that, that is varying element. Okay, so here you can see the get area varies by the type of shape. If you want to calculate the area of that shape, then which shape we want to calculate the area for. Okay, so here the get area varies by the type of shape, so we assign the responsibility to that subclasses. Here you can see two subclasses are there. Okay, so by sending message to that shape object, a call will be made, that is get area. A call will be made to that corresponding subclasses, that is circle or triangle. We are going to calculate the area for the shape. That shape may be either circle or triangle. Okay, that is the polymorphism. Okay, so this is all about polymorphism pattern. So we have seen three patterns here, that is controller pattern. Okay, here we have seen controller pattern, then benefits of controller. Okay, then example of controller pattern. Then blotted controllers we have seen. Then high cohesion. What is low cohesion and high cohesion we have seen. Then polymorphism. Polymorphism means it guides us to decide which object is responsible for handling those varying elements. Their varying elements is where we are going to calculate the area or the type of shape is varying element here. Okay, we are going varying element here. Okay, so that's it for today's session. We will stop here. Thank you.